Hello, Assalamu alaikum friends. This is Mohammad Inam, and in this video we are going to talk about chain rule for function of one variable and two variables. Chain rule is the basic concept of derivative for function of one variable and two variables. Sometimes people stuck while taking the derivative of function of two variables and the total derivatives, and it depends on how many independent variable do you have. Chain rule and total derivative or differential both are actually combined topic, so I'm consider these two topics in this video. In this video I have also some examples which are basics and general. Okay, let's start with chain rule for function of one variable. This is the fundamental or the basic function. Here f and g are written as composition and like f of x. So the derivative, we always take derivative with respect to its argument, and in this case dy by dx equals to the derivative of function f with respect to its argument, which is g of x, and multiply the inside function derivative with it. This is the chain rule for function of one variable. Here, here is one example which is associated with the previous case, that is the derivative of dy by dx is equals to derivative of exponential function with respect to its argument, and the derivative of its argument with respect to x. Now we know the derivative of exponential function is same, so this is same, and the derivative of 2x with respect to x is just 2, so this is the derivative of the above function. Okay, now in this slide I have a chain rule for function of one variable in general. Means here we have the composition of nth function f1, f2, f3 and f1 of x, and we are going to take the derivative of this function. So how can we take the derivative of y with respect to x? It's just same, the idea is same. The derivative of first function with respect to its argument multiply the derivative of second function with respect to its arguments, and so on, the final function and its argument. Now this is the general idea how to take derivative when you have composition of nth functions. So if you use this way, then you can easily find the derivative with chain rule for function in one variable. Now I have example here. This is the example of the previous case. Here the f1 is sine of x, sine theta, let me say sine theta, and f2 is log of x, and f3 is x square. So here I have three functions, and the composition of three functions means you can say that f1 composition f2 composition f3, and this is the composition which is the result. Now we are going to take the derivative. So the derivative of the upper function is simple. You can find the derivative of sine with respect to its argument, and the argument of sine is log x square. Now inside function log x square with respect to its argument, and the last one dx square by dx. Now the derivative of sine is simply, we know that it's cosine log x square, and the derivative of log is just x square, and the derivative of x square is 2x. So this x is gone with this one, and we have the result, left result, it's 2 cosine log of x square x. This is the derivative of this function. The idea is same. We have just take the derivative of orthogonal function with respect to its argument, then so on, and we find that our result. Now, in one variable case, the chain rule is easy. Mostly people can easily solve this chain rule for function of one variable. But when we are in function of two variables, just like this one, most of the time people stuck. Now this is the simple function. I represent function f. This is the variable z, and this function z is depends on two independent variables. One is x and second one is y. So in this case, the symbol of derivative is changed, which is this one, and sometimes called dava and sometimes it's partial. So partial z by partial x is equals to partial f by partial x. The derivative of z with respect to x is just a derivative of f with respect to x. And simple, the derivative, partial derivative of z with respect to y is just partial derivative of f with respect to y. Why we have partial derivative? Because f is dependent on x and y, two independent variables. In the next case, now this is the interesting. Z is function which is dependent on f. F is dependent on x and y, and x and y both are dependent on t. So in this case, I use the notation d. Now this d represents the differential, and the partial shows you the partial derivative. Now why I use d? Now think, just you have to think. The function z is dependent on x and y, while x and y both are dependent on t. Means we have only one independent variable, that is t. So, and we are going to take the derivative of z with respect to its independent variable. That's why it's a total derivative. How can we take it? Just partial f by partial x, because f is dependent on x. Then dx by dt. Why d? Because x is only depends on t, and this is chain rule. Plus y plus, because partial f by partial y, f is also depends on y, and dy by dt, both, and y also depends on t. Why we have these terms? Because we have to take derivative with respect to t, and z depends on xy and xy depends on t. This is called the total derivative, because we have only one independent variable, that is t. And the chain rule also. Sometimes people write to like this as dz partial f by partial x, it's fx, well, derivative of f with respect to x, and x dot of t plus fy and y dot of t, or or dz equals to fx and dx plus fy dy, and just these are the notations for total derivative. Okay, in next slide I have one more complicated example, which is now z is depend on u and v, while u and v also depends on x and y. And now let's think, how many independent variables we have? We have two independent variables, x and y. So in this case, we have to take partial z by partial x. We can take only partial z by partial x either, or partial z by partial y. Now how can we take the derivative? Partial f by partial u, because f is depends on u, and partial u by partial x. U is also dependent on x, but u depends also on y, so we have take the partial derivative, plus partial f by partial v and partial v by partial x. This is the partial z by partial x, and similarly partial z by partial y, partial f by partial u times partial u by partial y, plus partial f by partial v times partial v by partial y. These are two cases, the total derivative with respect to x and total derivative with respect to y. In the next, we have a very complicated example. In this case, you can see the f is depend on u. U also depend x, y, while x, y are depends on t. V also depends on x, y depends on t. Then f also depends on x, y, and t itself. Now, in this case, the independent variable is just t. This is only independent, while other all are dependent variables. So we take the total derivative dz by dt. Now, first of all, the derivative of, we get partial f by partial t, because f depends on t, plus partial f by partial x times dx by dt. F also depends on x and x depends on t, plus partial f by partial y dy by dt, plus f partial f by partial u. F depends on u depends on x, and x depends on t. Similarly, partial f by partial v by partial x, and dx by, sorry, I think it's no, dx by dt. Okay, two more terms, we have two more terms, plus partial f by partial u by partial y, and dy by dt, because u also depends on y and y is also depends on t. That's why we have these terms as well, partial f by partial v by partial y dy by dt. Now this is the total derivative with using of chain rule. We have this one. Okay, I hope the idea is clear. Otherwise you can ask in the comment section. And the last example, this is more complicated, and these types of questions always appear in GRE test type, means international mathematics test. So we have to be clear our idea, and it is also useful while doing some research paper in differential geometry or differential equations. Now we have to see how many independent variables we have. I can see that u is depends on v and y, while v is dependent on x and y. So we have two independent variables, one is x and second one is y. So let's start with partial z by partial x. Now partial z by partial x, it means partial f by partial u, and partial u by partial v, and partial v by partial x. F depends on u depends v, and v depends on x. Now plus partial f by partial v, and partial v by partial x, and this is the derivative or total derivative with respect to x of this function, this type function. Now if I'm taking the derivative of the above with respect to y, then first of all f depends on y, so the first term is partial f by partial y. Now plus, similarly, partial f by partial v, and partial v by partial y, plus partial f by partial u depends on v as well as y, partial f by partial u, partial u by partial y, plus partial f by partial u by partial v, and now partial v by partial y. U depends on v and y. So first we have take derivative of u with respect to y, and second we have take the derivative of u with v, which is this one. And this is the two cases. The total derivative and chain rule is used frequently in function of two variables, but the total derivative and partial depends how many independent variables we have. Now next I have an example, and this example I have copied from the Cracking GRE Mathematics book. So you can see that z is dependent on u, v and x, where u, v and x is v square minus 2ux, vxy is y plus xy square, and u this one, and we have to take the partial z by partial x. First of all, we derive the general expression for this function. So I can see that partial f by partial u, because f depends on u, and partial u by partial x, u depends on x, plus partial f by partial v, f depends on v and v depends on partial v by partial x, plus f is also depends on x, partial f by partial x. Now we have these, this is the general expression. We just take these things from the given data and just put in this expression. So this is partial f by partial u, means inside partial f by partial u. Here this is v square, no u term, is 0, it's constant and 0, and this is partial f by partial u, and now partial f by partial v, it's just 2v. And what we need next, partial v by partial x. Let me say partial, okay, let me put here partial f by partial u, it's minus 2x, sorry, partial f by partial, yes, minus 2x multiplied partial u by partial x. Partial u by partial x is 4y minus 1, 4y minus 1. Now plus partial f by partial v, it's 2v. Now partial v by partial x, partial v by partial x, it's y square, plus partial f by partial x, partial f by partial x is minus 2u. And just simplifying this one, we have minus, it's minus 8xy and plus 2x plus 2vy squared minus 2u. This is the partial z by partial x. If you have any difficulties and questions, you can ask in comment section, and your questions will be highly appreciated. For next interesting topic, kindly comment me, and if you like the video, share it with your friends and also subscribe it. Thank you.